Hi everyone, I'm Lalit Singh. Welcome back. Now we have seen how we can debug our app. Now let's just learn about testing too. In this particular session, we are going to know what exactly is testing, why exactly it's worth our time, and what exactly is unit testing. First thing first, why exactly testing is needed? Now, let's say you are developing your application and you have released your application into the market. Now, people find that there is a error or there is your application is not performing or giving the desired result. Now, your application comes back to you, and now you have to find all the bugs at that point of time at the production level. So the cost will be higher at that point of time. So it is good that if you find the bugs at the early stages of development itself. So that's why testing is needed. So find and bugs at early stages will cost you less and will take less effort. With the increase in time with with the increase in time with the development in your application, it will take much more time to find your bugs, and it will be much expensive too. Types of testing. When we talk about types of testing, there are levels of testing also, known as component testing, integration testing, protocol, and system testing. In component, we test component-wise integration. We put it as whole protocol. Protocol testing is related to the protocol we define, and system is testing the whole system itself. When we talk about types of testing, it can be a testing type. You can test it with the installation. You can test whether it is giving you the compatibility, or if it is acceptable to the user, if the performance of that particular application is adequate or not, or the scalability. In the same way, there can be a user testing also. When we talk about user testing, it can be automated UI testing or instrumented UI testing. And we will talk about UI testing more in our further sessions. Let's just talk about test-driven development. Now, this is the process you will be following every time you want to test any application. First, you will define a test case according to your requirement. For example, let's say you are testing a Kelsey. At that point of time, you require to make your test cases according to the Kelsey. Now, let's say you are using a database application, then your test case will change according to your database requirement. Maybe you want to check out whether you are getting all the records whether you are getting all the records or not. Now, once you make all the test cases, then you have to write the code regarding to that conditions. And once you put the code, then you have to test that test cases. You will get two results. One will be your actual result. Another one will be your expected result. Now, if there is a difference between them, that means your test has failed. Then you have to repeat all those steps again. When we talk about the testing your project, where exactly you can find your test projects. Now, in your Android application, when we talk about your Android application, there are mainly three projects. One is known as main. Inside main, you will put all your development classes. Then we have test package, in which you will be putting your unit test classes. Third is known as Android test, in which you will be putting all your instrumented test classes, or we can say UI testing classes. Let's just talk about local unit test classes, because that's what we are going to cover in this session, unit testing. Unit testing is testing a smallest unit or smallest component of a project or a program. You will be testing a component individually and getting the result back. In this way, you will be testing many single unit, or in this way you will be testing many components, many single components, and getting the result back. Each component unit will get the inputs, and there will be a result, and there will be a graceful failure. Now, don't think that at the very first try you will pass the test. There will be errors, there will be failures. Now, every time you get into the failure, you have to change the inputs. You have to keep on trying to change the inputs and get the expected result. When we talk about JUnit testing or local testing, they are being performed inside your JVM only. So you do not need any emulator while you are doing the JUnit testing. So whenever you will be performing the JUnit testing, all you have to do is, all you need is your Android IDE, and when you will be running the test, the result will be inside your console itself. You will be able to see in the console itself. All the test classes which you will be using in your local JUnit testing will be taken from JUnit class. Local JUnit testing classes are gathered inside the package source, and inside that there will be a test package, and inside that there will be Java where you will be putting all your JUnit test classes. Only JUnit class is needed to import. Only JUnit class is needed to import. No Android framework class is needed while you are doing your JUnit testing or local unit testing. Android framework class will be needed when you will be doing your Android UI testing. While we are performing our JUnit testing, you need to import all your JUnit classes like JUnit.test, JUnit.before, JUnit.run with, JUnit.ju or JUnit.runner.junits. So all these classes will be used inside your local testing. Now, to perform the unit testing, the very first annotation which you need to provide is @runwith, in which you will be providing the class which you will be using for this local unit testing, and that would be JUnit4.class. And you give the class name, maybe public class, my own class, and inside that you will put the methods. Now, to make any method behave as a testing method, you have to put an annotation @test. If you do not put @test annotation, now at that point of time, that method will behave just like any other Java method. To make your method behave as a testing method, you have to put annotation @test. Once you put the @test annotation, now when you run your testing class, your method will start testing whatever the code you have given inside that particular method. @annotation has been inherited from your JUnit4 test class only. And it is not necessary to put the test prefix before your testing methods anymore. You can just put any method name, and if you want to make that method name if you want to make that method as testing method, all you have to do is put the annotation @test. Now, if you want, before you start your testing method, you want to initialize certain variables or objects, you will be using a method called setup. Now, this setup will only run before the testing method if you put an annotation known as @before. Once you put the @before, whatever the data you have given inside that setup method, it will run before your testing method. Teardown is the method which will always execute once your testing is done. Now, there might be a chance that while you were testing your application, you must have used many resources. After you are done with your testing, you do want to release all those resources. So how exactly you make any method behave as teardown method? For that, you need to include an annotation known as @after. And once you do that, the method will be executed right after your testing is done, and you can release all the resources inside that teardown method. So how exactly testing is done inside your Android Studio? To perform testing, either you can right click on your testing class and then run your class as a testing class, or you can right click on your testing package and then run your package as a test package. In both the cases, it will start running your application in testing mode. If all the testing cases and all the testing methods which you have defined inside your testing activity or application are passed, then only it will show you a green progress bar by telling you that the test has passed. If there is even a single method or testing case which has been failed, it will show you a red progress bar telling you that this is where your test got failed. When we start testing your floating point, we have to take extra care with the floating point. The reason behind that is because floating point has a precision value also. For example, let's say I have two values to add. Now, once I add these two values, I will get a result back. Now, if that result is, let's say, for example, if that result is 50.0.000.4, but I'm only getting 50, then there will be a error and your test will not pass. So that's when you want to provide some relaxation or some precision value to your floating point numbers. So you can do that with the help of assert equals. Assertion methods are used for checking out your test cases. You will be using all the assert methods to check out your test cases. Here you can solve this error by providing a particular range of value till which you want the relaxation. For example, that same value 50.00005. Now if you do not want to care about the decimal point, there will be a third argument where you will be providing till which point you do not care about the precision value. And once you provide that, your test will get passed. To learn more about your testing, you can follow the following links. Next we are going to go with the unit testing practical.